Hi everybody, welcome back to this course on internet technologies. I'm Vardhan and today we'll be studying about mail access protocols like IMAP and POP3. But before we dive deep into how mails are retrieved, let's quickly recap how mails get sent using SMTP. When you connect to an SMTP server, say through a simple telnet session on port 25, the server greets you with a message like 220 server name service ready, and then you start your conversation. First, you say send a hello command along with your domain name. The server acknowledges with a 250 hello, your domain, that response. This is the starting handshake before the actual message exchange begins. Next, you declare who the mail is from with mail from command, then the sender email address. The server would reply 250 OK. Then who it's for, RCPT2, the recipient email address, again 250 OK. To start writing your actual email content now, you would have to send data command. The server will respond 354 start mail input, end with crlf.crlf. Now, what's this crlf? So, crlf means carriage return followed by a line field, especially a new line. So, when you type your text message, you would type it line by line. Once done, a single full stop on a new line signals the message completion. That's what it means. So if all is well in the end, server would send again a 250 message OK, message accepted. Finally, you would close the connection with quit and get 221 closing connection. A big problem with traditional SMTP is that it was designed without security in mind. There's no built-in authentication, so anyone can fake sender addresses. This is called spoofing. To counter this, modern email systems use standards like SPF, that is Sender Policy Framework, which ensures mail from a domain is sent from authorized servers only. Another is DKIM, Domain Key Identified Mail. It digitally signs emails for authenticity. DMARC is something, it builds upon both SPF and DKIM. It enforces domain policies and protects the receivers. And most internet service providers today enforce these checks to stop email based abuse like phishing and spam. So, in practice, a mail client like Mozilla Thunderbird or web client like Gmail talks to an SMTP server to send mail. The same server also runs POP3 and IMAP to handle mail retrieval. And these mail access protocols like POP3 and IMAP allow your mail client to retrieve or manage messages from the server. So SMTP is great for pushing messages out, but it can't pull them into your inbox. Once a mail reaches your server's mailbox, you need mail access protocols to retrieve them. So Post Office Protocol version 3 is one of the simplest and oldest protocols for retrieving emails. It operates over TCP port 110, and POP3 typically works by downloading messages from the server to your device and then deleting them from the server. This makes it lightweight and easy to implement, but it lacks features like folder management or synchronization. Also, if you access emails from multiple devices, say a phone and a laptop, POP3 can be problematic because downloaded mails won't sync across devices. To address some of its limitations, POP3 offers two modes. In delete mode, mails are removed from the server after you download them, and in keep mode, a copy stays on the server even after download. However, even in keep mode, there's no folder or sync functionality, and many servers historically didn't even offer this option. Now, Internet Message Access Protocol is much more advanced. It uses TCP port 143, and when using IMAP, only message headers are fetched first. So you can selectively download messages based on looking at the headers first. You can also perform keyword based search on the server, and you can manage folders and make subfolders. And most importantly, your mailbox is synchronized across all devices. So if you delete a mail on your phone, it's deleted on your laptop too. This makes IMAP the default choice for modern email clients. So now SMTP was designed for plain 7-bit ASCII text, so it couldn't handle images or files. That's where MIME or multi-purpose internet mail extensions come in. MIME is not a protocol, it's a translation layer. So MIME converts binary attachments like images, videos, and documents into text-friendly formats so they can be safely transmitted over SMTP. It essentially makes email usable for modern multimedia communication. When an email contains multimedia content, MIME adds additional headers like MIME version, content type. So content type defines the data type like text or image. Content transfer encoding describes how the content is encoded, like for instance base64 encoding. Content ID uniquely identifies attachments or inline images. Content description optionally describes the content's purpose. These headers help email clients properly display and handle diverse content types. So base64 encoding is a great example of content transfer encoding. It converts binary data like images into 7-bit ASCII. It works by taking 3 bytes of binary data and converting it into 4 printable ASCII characters. This ensures binary files can safely traverse the email systems, which are traditionally designed for text. A downside is that it increases the size of data by about 33%, but it's essential for reliable email attachments. So that is the end of this video, and the next lesson would be about the World Wide Web and Hypertext Transfer Protocol. So thank you for joining in, and I'll see you next time.